Students, today we'll take chapter 3, Understanding Quadrilaterals. Here you are seeing certain types of curves. Some are like, here you can see a shape of 8 over here. This shape is something circular like, and here you are seeing an open-ended shape. Here again an 8 is there. Here the line is crossing each other. So you are seeing here different types of shapes. Now we are going to classify them into simple and not simple curves. Now first let us take two simple classifications. The first simple classification is this a closed curve or not a closed curve? If it is a closed curve, then is it a simple closed curve or just a closed curve? So here we are two figures. The first one is only closed curve, but it is not simple. Why it is not simple? Because here the two lines are crossing each other. This one is a simple one because none of the line is crossing each other. It is like a loop, but the loop is closed. Therefore, it is simple closed curve. Now, one more classification. Is it a closed or an open curve? So here one you see that it is an open curve, but this is a closed curve. Like if I can say that one insect is there, now it has been locked inside this loop, right? And if it wants to come out, then it will not be able to come out. That time you can say that it is a simple closed curve. But here, if an ant is there and it is entering this loop from this end, then it can move out of the loop from the other end. Why? Because it is open. So such curves are called not closed but simple. Why simple? Here the loop is not crossing each other. It's simple one. No crossings are there. What about this? Here again it is closed because there are no ends open, and it is simple because none of the lines are crossing each other. This again is a closed curve because you cannot see any open ends, but it is not simple. Why not simple? See, this line is crossing the other line. Now this is not simple and not closed. Why not closed? Like if you can say that if an ant is passing through this line, it is going to come out through this line. There are ends are open. See, this end is open and this end is open. So when the ends are open, it is not closed. Here you have to classify this among, like you have to match them, right? Now this type of line, it will come under which category? It is a simple curve, but it is not closed, right? So it is simple curve that is not closed. And what about this? It is having open ends, hence it is not a closed curve. It's not also simple because it is crossing. So it is not a simple curve. It is crossing. See, the two lines are crossing each other, then it is not simple. What about this? There are no ends open. The whole curve is closed, but no lines are crossing each other, hence it is simple. This is a simple closed curve. Over here it is. And what about this? See, these two lines are crossing each other, hence it is not a simple curve, but it is closed. So it will come under a closed curve that is not simple. It is closed but not simple because of these two crosses, the crossing lines crossing each other. Now we'll talk of polygons. What are polygons? Now previously we read about what are closed curves. So polygons are definitely closed curves, but they are not made up of any circular lines. No curves are there. All the curves are straight, like they are line segments. It will have only line segments, nothing like a curve, as well as they are closed. They must be closed and they are made up of only line segments, nothing like a circle, no curved ends. So here you see all are line segments, and another condition is that they are closed. The curve is closed. This is a closed curve and made up of only line segment. All these three are having the same property, made up of line segments and closed. Such curves are called polygons. Now these are not polygons. Why? Here the case is very simple. The ends are open, hence it is not a polygon because a polygon must be closed curve. Here it is not simple. The polygon should also be simple one. Here it is, the simple closed curve. This is not simple. Why? Because one of the line is crossing the other two lines. See, these two lines are crossing this line. Hence, if there is crossing, then it is not simple. Here also the same case. It is crossing, therefore it is not simple. It is also not closed because the ends are open. Here we have classified polygons. We are having types of polygons with their names. If there are three sides, it means there are three line segments, then it is called triangle. Four line segments, then quadrilateral. Five line segments, pentagon. Six, hexagon. Seven, heptagon. Eight, see this, these are eight line segments. Octagon, 9, nonagon, 10, decagon, and many more. You must know up to 10. That is mandatory. You should know in this 8th class at least the names up to 10, up to the shapes of polygons having 10 line segments. Just try to draw these polygons and write their names with correct spelling, which is very important. Now here these are types of polygons, but they are regular. Now I will explain you what means regular. In regular polygons, all the line segments have equal length and the angles are also equal. Like if this triangle is an equilateral triangle, then it is a regular polygon. See over here, if it is an equilateral triangle, then all the angles will be equal. What is the measure of it? Of an angle in an equilateral triangle? It is 60° each. And all the line segments are equal, having equal measures. Then it is a regular polygon. Here it should be a square. A square is a regular polygon because the angles are equal and the length of the line segments are also equal. A pentagon will also be regular if all the angles are equal and the measures of line segment are equal. It means sides are equal and angles are equal. And these all, as you can see, are regular polygons. Now what are convex polygons? They have no portion of the diagonals in the exterior or any line segment joining any two different points in the interior of the polygon lies wholly in the interior of it. Like this, see the diagonals. All are in the interior. All these diagonals are in the interior. Then it is a convex polygon. Then one more property about the convex polygon is that it will intersect the polygon, the line drawn through the convex polygon. This line is drawn through. Through means it is cutting in and out, throughout. That line segment will intersect the polygon exactly at 2 points, and it will divide the polygon into two equal pieces. As you can see, one piece is here and the other piece is that side. So this polygon is divided into two pieces by this line segment, and this line segment is cutting the polygons only at 2 points. Then it is a convex polygon. Now what is a concave polygon? In this polygon, this is not convex. Why it is not convex? It is a simple polygon if at least one of its internal angles is greater than 180. Now here you can see this angle, it is greater than 180. Even if one angle is greater than 180, then it is a concave polygon. Right? Now if we take a star polygon, then it is also concave polygon. A concave polygon must have at least 4 sides. Now here if we try to draw a line through a concave polygon, it will cut at more than 2 points. Here you can see it is cutting at 1, 2 and 3 points. And it is dividing this polygon into how many parts? More than 2 parts. 1, 2, 3, right? There are more than 2 parts. This polygon is divided by this line at more than 2 parts. 1 part, 2 part, 3 part. So then it is a concave polygon. One more property about the diagonals of a concave polygon is that the diagonal will lie outside the polygon. Not all the diagonals, some of the diagonals. Here you can see one diagonal is lying outside the polygon, others are inside, but one is lying outside the polygon. Even if one is lying outside the polygon, then it is concave polygon. In this star, you can see many diagonals will lie outside the polygon. Here this one, and this one. So like that, many of them will lie outside the polygon. So many diagonals are lying outside the polygon. Then it is a concave polygon. And what about this one? This one. So this is also lying outside the polygon. Should be straight, right? So these are concave polygons because even if one diagonal is lying outside, then it is concave. Here you can see one is inside, but we did not talk about the inside one. We are talking about the one that is outside. If even a single diagonal is outside, then it is a concave polygon. Difference between here you drag a concave and convex polygon lies in the measure of their angles. For a polygon to be convex, the interior angle is less than 180 degree. Otherwise, then it is a convex polygon. So in convex polygon, all the angles are less than 180. It means it is bulging outwards. In concave polygon, and in as you will find at least one angle greater than 180. Now see, this is concave. Why? It has become more than 180 degree. The angle has become more than 180 degree. It has become 196 degree. So a convex polygon can be defined with all its interior angles less than 180 degree. You drag any of the vertex. If it becomes more than 180, see the red line came, and can you see over here it is concave. Now again drag it here. See it is less than 180, it is bulging outwards, the polygon, then it is convex polygon. All the interior angles are less than 180. Once if any vertex point invert towards the center of the polygon, then it ceases to be convex. Means, see here we have, it is interior, it is going inward. See, it is going inward, here outward. This is inward, this is outward. Outward means convex. Convex means less than 180 degree. When it is inward towards the center, then it is not convex, it is concave. You even watch over here. The name of the polygon changes and here a red line will appear. Red line shows that a red color will appear in the degrees. The red color shows that it is more than 180 degrees. See, more than 180 degree, and it is pointing inwards. The vertex is pointing inwards. Now you see it slowly it is becoming less than 180 and it is becoming a bulging polygon. Take any of the vertex, drag inwards. See the red here, the red degrees have appeared and here you can see it became concave. Again you slowly drag outwards, less than 180. Less than 180 away from the interior and bulging, that means convex. Less than 180 away from the interior and bulging, that means convex. Towards the interior more than 180 and it is inwards, towards the inwards. It is not bulging. And it is more than 180, then it is concave. Now what is a diagonal? A diagonal is a line segment connecting two non-consecutive vertices of a polygon. What means non-consecutive? Now suppose you give your this point number 1 like this. If this is number 1 and this is number 2, this point is number 2, this vertex, right? And if this vertex is number 1, then these two are consecutive. And if you join these two consecutive vertex, you get only one line, side. You get one side. But in diagonal, what you are supposed to do, you don't have to talk of two. You should talk of non-consecutive. Means you need 3. Over here it is 3. And then you join 1 and 3. See, they are in opposite direction. Hence it makes a diagonal. You can even join 1 and 4. It is also a diagonal. You can join 3 and 5. This is 5. You can join 3 and 5. But when you talk of 1 and 5, it is a side. It is not a diagonal. So in diagonals, you have to miss one consecutive number or one consecutive vertex and then you should take the another. 3 and 5 if you join, then you get a diagonal. If you join 3 and 4, you get only one side. Here also you are seeing that A and C are non-consecutive. Why? The consecutive vertex of A is B and on this side also it is, on this side it is B and this side it is D. So we should not talk of consecutive vertex. We should talk of non-consecutive. So A and C are non-consecutive. When you join them, you get a diagonal. Similarly, this is also a diagonal. It's joining opposite vertex. Here also you find this is a diagonal. Why? Because they have skipped consecutive vertices. Here you can join this two. This is also diagonal. This is also diagonal. Here this is also diagonal. So like this we can find diagonals with non-consecutive vertices of a polygon. Here you can see this is interior of a closed curve. It is shaded, and here the outer side is shaded. This is exterior of a closed curve. Like in this interior, this is interior which is shaded, and this is unshaded portion is exterior of the circle. Now here you are seeing the concave polygon. It is not bulging. One side is bent inwards. One of the angle is bent inwards. Here it will be bent towards the center. Here nothing is bent towards the center. All are bulging outside. Then it is convex. Here again one is bent inwards. But here be careful that this inner angle is greater than 180, not the outer one, not this one. Only one inner angle is greater than 180, hence it is concave. And you can see that it is moving towards the center. It is pointing towards the center. Here none of them is pointing towards the center in convex. In convex, none of them is pointing towards the center. All are bulging outside. Regular and irregular polygons. A regular polygon is both equiangular and equilateral. For example, a square has sides of equal length and angles of equal measures. Hence, it is regular polygon. I already told you that a square is a regular polygon. A rectangle is equiangular but not equilateral. It means the sides are not equal. Only opposite sides are equal. All the four sides are not equal. Therefore, is the rectangle a regular polygon? Think it over. And is an equilateral triangle a regular polygon? That also you think it over. Here, if the sides are equal, then we mark it with one stick this way. If the angles are equal, then they will have similar angles form. Like if they are curved once, then all will be curved once. Here they are curved twice, then two curves will be shown over here. This is mathematical representation of showing any equal angles. And this is how it is represented to show equal sides. If you want to show unequal sides, then it will be like this. See, one we have cut over here, and here there are two cuts. It means all the sides are not equal. Only these two sides are equal. These two sides are making a pair of equal sides, and these are making a pair of equal sides. Hence, this is not a regular polygon. This is a regular, or no, this is also not. Here you can see, but it's not visible properly. There are two sticks, two cuts, and it is already even visible that it is a rectangle. All the angles are equal, no doubt, but the sides are not equal. Therefore, it's not regular. This is equilateral triangle. It is regular. What about a right triangle? A right triangle has the hypotenuse, which is the largest of all the sides. It means all sides are not equal. Then is it a polygon? Think it over. Is it a regular polygon? Think it over. It means whether it is a regular or a irregular polygon. Now these are regular polygons, it's quite evident. All the sides are having one cut and all the angles are having only same one curve. Here also all are having same type of angular representation and the cuts are also same. Therefore it's regular. Here it's all quite evident. Here there are two cuts but here one cut. Similarly these two angles are represented in a different manner, means these two are making a pair and others are different. They are having only one curve. Here itself these two are having same measurement but not the others. From this it's quite evident that these are regular polygons and these are not. Here is an assignment for you. How many diagonals does each of the following have? A convex quadrilateral, a regular hexagon and a triangle. So do it properly. All the best and practice properly. Thank you.